Friends, very good morning to everyone. We were dealing with photoreactions, all the reactions which are induced by the light as the energy are photoreactions. The natural process like photosynthesis, two, the man made reactions including photosubstitution, photoaddition, photo-oxidation reactions we have come across. And we looked at the examples of these types of reactions. Today's subject of discussion is the continuation of these photoreactions, that is, photofragmentation. As the name indicates, it is the reaction induced by light energy where the fragmentation of the molecule takes place. In this fragmentation reactions, the organic compounds absorb the light energy and it gets to excited state, giving rise to the radicals or free radicals, and this get introduced as a functional group on the inactivated carbons. In these reactions, the intermediates like radicals or the intermediate zwitterionic intermediates like carbenes or nitrines are formed. In general, photochemical reactions are homolytic reactions and only the radicals are involved. Here, the zwitterionic intermediates are also involved. That is the uniqueness of this photofragmentation reaction. The first variety of photofragmentation reaction is alpha cleavage. Fragmentation means it fragments into smaller molecules. This there should be a cleavage. The cleavage occurs at alpha position. That's why it is named after as alpha cleavage. This alpha cleavage occurs in those organic compounds in which the sigma bond is directly attached to the chromophore. A chromophore is one substance or the functional group present in the molecule which is responsible for absorption of energy. And if there is a sigma bond directly attached to the chromophore, then this kind of organic compounds, the alpha cleavage can occur. The primary process in alpha cleavage is homolytic photofragmentation. Homolysis is a reaction in which lysis of the bond takes place, giving rise to free radicals. These free radicals are diradicals in this case, and that is followed by the thermal process with the loss of carbon monoxide, carbon dioxide, nitrogen, oxygen, etc. to give the compounds. Here, the carbonyl is the chromophore and there is the bond, sigma bond attached to the chromophore directly. When sigma bond is attached to the chromophore directly, it is eligible for alpha cleavage. It absorbs the light energy and the electrons from the ground state, jumps to the higher energy states and get into the excited state. The bond cleavage, which is attached to the carbonyl group directly, that bond gets cleaved. That's why this sigma bond gets fragmented in the cleavage over here. When it gets excited from the lower energy ground state to the excited state, it is represented as star. It gives rise to one electrons moves towards the oxygen, another electrons moves towards the carbon, and the CO diradical is formed. The CO diradical which is formed, one electron moves over here and another electron from oxygen moves over here, and the bond cleavage occurs over here at the alpha position to give rise to two fragments. One is the carbonyl radical and another is the trialkyl radical. This radical can access the functional group to the with the it reacts with the other organic compounds where there are having inactivated carbons, and this attaches as the functional group to those molecules. Another variety of reaction is beta cleavage. This beta cleavage occurs when the living group is directly attached to the alpha carbon. This is an example of a beta elimination type of reaction. For example, diazoalkane. Here nitrogen N double bond N is an easy living group, is directly attached to the alpha carbon, then beta cleavage occurs. It absorbs the light energy, it gets excited to the higher energy level. In the excited state, the pi bond cleaves, one electron moves towards the nitrogen, another electron moves towards the carbon, giving rise to diradical as it is given in the alpha cleavage. The carbon nitrogen bond which is formed, one electron moves towards the nitrogen, another electron moves towards the carbon, and it gives rise to a carbene and the nitrogen, which moves as N2. The excess electrons on this nitrogen moves towards the electron deficient nitrogen. It becomes N triple bond N and it escapes as nitrogen molecule. As I showed, it is a thermal process where nitrogen or oxygen or carbon dioxide or carbon monoxide gets eliminated, and the carbon which is formed reacts with another organic compound to give a functional group to those carbons. This is all about the photofragmentation reaction. We have seen various varieties of photochemical reactions starting from photosubstitution, photooxidation, photoaddition, and photofragmentation. There are few compounds which do not absorb light energy, maybe due to the loss, non-availability of the functional groups. Even in those cases also, we can make photochemical reactions by using photosensitizers. The photosensitizer is a substance which is foreign to the molecule. It's a foreign substance which is added The foreign substance absorbs the radiation, it gets excited, and this excited foreign substance transfers the energy to the reactants, which are not directly absorbing the light energy, and then makes it the reaction to occur. And these foreign substances which are added are called as photosensitizers, and the process of activating the non-absorbing molecule by adding a foreign substance like photosensitizer and making the reaction to occur is this process is called as photosensitization. There are two varieties of photosensitizers used. The first variety is the atomic photosensitizers. They are like metals like mercury, cadmium, zinc, etc. can act as atomic photosensitizers. There are molecular photosensitizers like benzophenone and sulfur dioxide. And once this excited foreign substance, it collides and transfers that energy to the colliding substance, and it loses its energy and gets converted into the other product, and this process is called as quenching. The photosensitizer transfers the energy to the reactants by the process of quenching. Dissociation of hydrogen molecule is an example for photosensitization reaction. Hydrogen molecule as such it do not absorb the light energy, and that's why it is sensitized by the foreign substance. We add small amount of mercuric vapors into the hydrogen gas, and mercury which is added helps in dissociation of the hydrogen. The mercury here act as a photosensitizer. Mercury absorbs UV light and it gets excited. This excited mercury acts as a photosensitizer and collides with the hydrogen molecule. And when it collides with the hydrogen molecule, it gets transferred its energy to the hydrogen, and the hydrogen molecules goes to the excited state, and the Hg which has transferred the electrons again absorbs the UV light, gets excited, and this excited mercury again reacts with hydrogen, and the process continues until all the hydrogen molecules will be in the excited state. This hydrogen molecule in the excited state is unstable, and this hydrogen excited molecules loses the energy, undergo dissociation to give hydrogen radicals. This is another photochemical reaction where we use photosensitizers and activate the molecule for the reaction to occur. This is all about the photochemical reactions in brief. There are many reactions which are undergoing photochemical reactions, many compounds, and still the process is continuing. This has gained importance because of the fact that those reactions which are not possible by thermal conditions can be carried out by photochemical method, and it is more eco-friendly, and hence it is an approach to the green chemistry. That's where it has its value, and it has added its value to the field of chemistry. Now you can appreciate the utility of photochemical reactions. In the next presentation, we can deal with the other aspects of green chemical reactions. Till then, have a nice day. Thank you.